In the last video, we saw how DNS converts a name like youtube.com into an IP address. But once your browser gets that IP address, the journey is not finished. Now your browser has to connect to something behind that IP. So the real question is, what is behind the IP address? That is where servers come in. An IP address usually points to a machine on a network. And on the internet, that machine is often acting as a server. So when your browser gets the IP address for a website, it is no longer just dealing with the domain name. It is trying to reach a machine that can respond with data. A server is simply a computer that provides something to other computers. That something could be a web page, an image, a video, a file, an API response, or data from a database. The important idea is this. A server waits for requests and sends back responses. This is called the client-server model. Your phone, laptop, browser, or mobile app is usually the client. The client sends a request. The server receives that request, does some work, and sends back a response. Most of the internet is built on this simple pattern. Client asks, server responds. For example, when you open a website, your browser sends a request to a server. The server sends back the data needed to show the page. That response might include HTML, CSS, JavaScript, images, or other data. Your browser then uses that response to display the website on your screen. So the website is not magically inside your browser. It is coming from a server. A server is not magic hardware. It is still a computer. It has CPU, memory, storage, and a network connection. The difference is its role. Your laptop is usually designed for one person. A server is designed to provide services to other computers, often continuously and at scale. A server does not have to live inside a data center. Any computer can become a server if it runs software that listens for requests and sends back responses. You could use an old laptop, a desktop PC, a Raspberry Pi, or a small machine at home. You could also rent a virtual server from a cloud provider. So server is not about the physical shape of the machine. It is about the role the machine is playing. When people say server, they can mean two things. Sometimes they mean the machine itself, and sometimes they mean the software running on that machine. For example, Nginx can be called a web server. PostgreSQL can be called a database server. So server can mean the machine, the software, or both together. Context matters.
Different servers do different jobs. A web server provides websites. An API server provides data to apps and front ends. A file server stores and sends files. A video server helps deliver video content. A database server stores and retrieves structured data. So server is a general concept. The exact job depends on what software is running.
Now here is the important part. One server machine can run many services at the same time. It might run a web server, an API server, a database, SSH, Redis, or monitoring tools. So the IP address gets your request to the machine. But the machine still needs to know one more thing. Which service should receive this request? This is the problem that ports solve. Imagine one building with many rooms. The building address gets you to the correct building, but it does not tell you which room to enter. In the same way, an IP address gets your request to the correct machine, but if that machine runs multiple services, the request needs one more piece of information. That piece is the port number. A port is a number that identifies a specific service running on a machine. The IP address tells your computer which machine to contact. The port tells it which service inside that machine should handle the request. So the simple mental model is IP finds the machine, port finds the service. Think of it like a building. The IP address is the building address. It gets you to the right location. But inside the building, there are many rooms. The port number is like the room number. It tells your request exactly where to go inside that machine. You will often see an address written like this: 142.250.190.14:50. 443. The part before the colon is the IP address. The part after the colon is the port. Together, they mean, go to this machine and talk to this service.
Some port numbers are commonly used for specific services. Port 80 is usually used for HTTP. Port 443 is used for HTTPS. Port 22 is used for SSH. Port 53 is used for DNS. Port 5432 is commonly used for PostgreSQL. And port 6379 is commonly used for Redis. You do not need to memorize all of them right now. Just remember that different services often use different ports. When you visit a website using HTTPS, your browser usually connects to port 443. So for YouTube.com, DNS first helps your browser find the IP address. Then the browser connects to that IP address using port 443. That port tells the server this is HTTPS traffic. For a port to work, some application must be listening on it. Listening means the application is waiting for incoming connections on that port. For example, a web server may listen on port 443. A database may listen on port 5432. Redis may listen on port 6379. If no service is listening, there is nothing to handle the connection. If a request reaches a port where no service is listening, the connection can fail. Sometimes you get connection refused. Sometimes the request times out. Sometimes a firewall blocks the port completely. This is why developers often check whether the correct port is open, exposed, and listening. If you are a developer, you have probably seen ports many times. A front-end app might run on localhost port 3000. A back-end API might run on localhost port 8080. A PostgreSQL database might run on port 5432. Ports allow multiple services to run on the same machine without confusing each other. There is one more useful detail. When your browser connects to a server, the server usually has a known destination port, like 443. But your own computer also uses a temporary source port. For example, your laptop might use port 53124 to connect to a server on port 443. This helps your computer know which connection the response belongs to. You can run a server from almost anywhere. But when companies need reliability, speed, security, and scale, they usually run servers inside data centers. A data center is a building filled with many server machines. These buildings have power, cooling, networking, backup systems, and physical security. So yes, a server can be your own device, but large internet services usually run servers in professional data centers or cloud platforms. Cloud providers like AWS, Google Cloud, Microsoft Azure, and DigitalOcean own and manage huge numbers of servers in data centers. Instead of buying and maintaining your own machines, you can rent servers from these providers. Your application still runs on servers, but the cloud provider manages the physical hardware, networking, power, and data center infrastructure. In the cloud, you usually do not rent an entire physical machine. You often rent a virtual server. A virtual server behaves like its own computer, but it may share physical hardware with other virtual servers. This makes cloud infrastructure flexible. Developers can create servers quickly, resize them, or delete them when they are no longer needed. Server location matters because distance affects latency. If your users are in Japan, a server in Tokyo will usually respond faster than a server on the other side of the world. That is why cloud providers offer different regions, like Tokyo, Singapore, Mumbai, Frankfurt, or Virginia. Choosing the right region helps make applications faster for users. A single server can only handle so much traffic. It has limited CPU, memory, storage, and network capacity. If too many users send requests at the same time, the server may become slow or crash. That is why large systems usually use multiple servers, load balancers, caching, databases, and other infrastructure. We will cover those later in the series. Let's connect everything together. You type youtube.com. DNS finds the IP address. The IP address points your browser to a server. The port tells the server which service should receive the request.
Then that service processes the request and sends back a response. This is a very important foundation for understanding back-end systems. Here is the simple mental model. DNS finds the IP address. The IP address finds the machine. The port finds the service inside that machine. And the server sends back the response. Once you understand this, the internet becomes much less mysterious. Now we know where the request goes. We know how DNS finds the IP address. We know that the IP points to a server, and we know that the port identifies the service. But one big question remains. How does data actually travel between your computer and that server? That is where TCP and UDP come in, and that is what we will explore in the next video.